Hi, welcome back. Now, dealing with real number system, we have dealt with rational numbers. In this episode, we are covering irrational numbers. This is another major type of real number system. Sorry. So let's see. Reading directly from the screen, and then where I have to talk, I have to be writing. I'll do that so that I don't waste the time. So now, an irrational number, right? We said a rational number is one that can be expressed as a fraction, right, with a terminating and recurring decimals. These are the factors that we learned or the takeaway. Now, what is irrational number? Irrational number is just the opposite. So it means that a number that cannot be officially or that cannot be expressed unless otherwise stated as what? As a fraction. Get this correct, because there will be an exceptions as we progress. So a number that cannot be expressed as a fraction unless otherwise stated as a fraction. So generally, it's not a number that can be what? Expressed as a fraction. So that is what it means. So a fraction means that we don't have a numerator and a denominator. And if the denominator is equal to you know something, let's just read. An irrational number is a number which cannot be written as a common fraction, right? A number that is a number which cannot be written as an what? Integer divided by an integer. That is a fraction. Now, for example, square root of 2 is an irrational number. Why? Another well-known irrational number is pi. You cannot find an exact value of pi. Now, someone be asking, wait, hold your horses. Because we said this number cannot be expressed as what? As a fraction. But a pi is what? 22/7. Hold your horses. Why pi is expressed as a fraction, or let's say a rational number, right? Because it has been expressed as 22/7. Now, if you should do a long division for this particular one, you realize that it is non-terminating. You will do it forever. Non-terminating, right? Non-terminating. You do it forever and you'll be tired. So per standard, according to mathematicians and scientists, they have to find a value for this, but it doesn't have the exact decimal place. We have taken it to, they have considered by standard to make it 3.142. But if you should do a long division like we did in the rational numbers and the rational number topic, you realize that you do it forever, indefinite, right? And that is not. So if you see this, it's because per standard they have expressed it that way. But pi is not a rational number, right? So it's actually an irrational number. So now, so values used for pi, such as 22 by or whatever, are only approximations per standard. The set of irrational numbers is denoted by the symbol h, right? H. Now let's continue. Now note that when an irrational number is written as a decimal, the decimal is infinite. It goes on forever. It goes on forever, yeah, of course, and has no repeating pattern. Thus, numbers which are decimals, numbers which are non-terminating and non-repeating decimals are irrational numbers, right? Because we saw that in rational numbers that these properties of rational numbers means that they are terminating and they are recurring. They are terminating and they are recurring, right? But here, the opposite what is true for this. So you realize that you do a long division, you are dividing and see that it continues, no particular pattern. You can't even use your dots on a particular digit or a set of numbers to make it a rational number. You realize that that is what? An irrational number. You can't express it as a fraction. You can't express it as a decimal. Because for a fraction, you continue, or for a decimal, you continue forever. That is it. So it doesn't mean you can actually be written as a decimal, but you can write it as a decimal, but it will continue forever. So that is it. I know in practice it may sound different as we are teaching. So that's why I'm restating my fact or saying it in another way, right? So let's look at another property. We are saying that the square root of a prime number is an irrational number. So now we are looking at the properties of what? Irrational numbers. We saw that they are what? They are infinite, non-repeating pattern, and non-terminating. That's one. The The second one is what? The square root of a prime number is an irrational number. What is a prime number? We saw that a prime number is a number which has only two factors, the number itself and 1. So it means that, for instance, if you have 2 as a prime number, it means that 2 times 1 is 2. There's no other factors or numbers that will give us 2. And 3 the same thing, 5 the same thing. If you look at 6 is not, because we have 1 times 6 is 6. You can also get 2 times 3 to give you 6. Hence, it is not a prime number. So that's what they are saying. So looking at that, we are saying that a square root of a prime number is an irrational number. For example, 2 blah 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 blah, it can be expressed in a rational form, a square root form, as square root of 2, square root of 3, and blah 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 forever. And they are saying that all these things are irrational numbers. You can check with your calculator. Now, third factor or property is that the product of two different irrational numbers is also an irrational number. The product, it means that when you multiply two irrational numbers, the solution, the resultant number, is also an irrational number. How? Square root of 2 times square root of 3 is square root of 6. And you know that. So that's what it means. Therefore, square root of 6 is an irrational number. Let's also go on. We are saying that also any rational multiple of an irrational number gives an irrational number. What does it mean? Rational multiple, 3 square root of 2, right? 5 square root of 3, 17 square root of 5. And we are saying that all these things are irrational numbers. Check with your calculator. Note, the mere presence of a square root or radical sign does not mean the number is irrational number. For instance, if I should write square root of 4, the answer is actually what? A rational number. We get 2. Square root of 4, we get 2. And this is what? What do you mean? This is a rational number or an integer. This is a rational number or an integer. If you remember what we did under rational numbers, where we did 2 videos on that. So rational numbers, we did that. Now square root of 4 is 2. This is a rational number, right? And even though this is irrational, so it's not. So we are saying that the mere presence of a square root or a radical sign does not mean the number is irrational. For instance, square root of 4, square root of 25 is 5, right? So here too, you see that. So, and all these are what? Rational. Since 4, square root of 4 is 2, square root of 25 is 5. And then this is 4. So I hope you get a point. Now, I will suggest that you take your time and watch the videos. Be writing things that, don't be reading math. That's one thing. Don't be reading math. It seems that in the book I am doing this. I'm doing it because I want you to be looking at the question, looking at the textbook, the pages, and how I come up with the answers or the explanation. And then the second reason is that because I don't have enough time to be writing and be explaining at the same time. That's why I prefer, if the textbook is explainable, I use it direct. Else I'll write in my book. I'll write it beforehand and I come and explain them to you. So that is why. And it's because of the lack of the following. At the moment, I don't have 1K followers that I can go live and be recording where you ask questions and then I explain. So now what we are doing so far is we are tackling the topics, treating them for conceptual knowledge, understanding. Then when there's time or when I hit the 1K on TikTok especially or YouTube, then I can do the live. I come back to the various topics once again. I may be taking questions under them. So thank you very much for watching. I will see you in the next episode. Follow, like, share. CMG-MathSpace. Step boldly into the math space. Bye for now.